as shown. What is the area of triangle ABC and of triangle ACD? Explain your answer. Well, we first need to remember that what the area of a triangle is. Area of the triangle equals half of the base times the height, or you can say that the area equals the base times height divided by 2. Looking at these triangles, we know that if this is 45 and this is 90, then this one also has to be 45, which means that this has to be an isosceles triangle, and this has to be 5 square root 2. So to find the area, we can do half of the base times the height. So 5 square root of 2 times 5 square root of 2 divided by 2. That's going to be our area for our triangle. In multiplying across the top, I get 5 times 5 equals 25. And the square root of 2 times the square root of 2 is the square root of 2. And the square root of 4, square root of 2 times square root of 2 is square root of 4. And then we can identify this as a perfect square. So we really have 25 times 2 over 2. So that's 50 over 2, which equals 25 units squared. Now we need to find the lengths of AD and AB. Let's start by finding the length of AB. So if you recall, the Pythagorean theorem says a squared plus b squared equals c squared. And the c has to be the hypotenuse, and that AB right here, this piece over here, is the hypotenuse of that triangle. So A, this is A, and this is B. So we're going to say 5 square root of 2 squared plus 5 square root of 2 squared equals c squared. In part A, we already did 5 square root 2 times 5 square root 2, and so we know that that actually comes out to be 50. Plus 50 equals c squared, which means we have 100 equals c squared, and then we have to take the square root of both sides of the equation, and we get that c equals 10. So AB equals 10. That's the length of the whole thing. So if this entire unit right here is 10, then we can say that this is an altitude. That means it cuts that in half right here. And so we know that AB equals 5. Now divide the length of the hypotenuse of ABC by the length of one of its sides. Divide the length of the hypotenuse of ACD by the length of one of its sides. So we're going to take the hypotenuse, which is 10, this triangle ABC, the hypotenuse divided by the side. Let's simplify that. 10 and 5, we can actually reduce. 10 divided by 5 is 2 over the square root of 2. And then, of course, we need to rationalize that denominator. So we're going to multiply the top and bottom times the square root of 2. And we get 2 square root 2 over 2. And then that reduces and gives me just the square root of 2. Now let's look at triangle ACD. To put the hypotenuse divided by one of its sides, we're getting this triangle right here. So one of the sides is 5, and the hypotenuse is 5 square root 2. As you can see, we can reduce that and we get just the square root of 2. Can you make a conjecture about these results?